Good morning, students. Uh, Today we are going to discuss and learn how to do boiling point determination of a given liquid compound. Now, let us first define what is boiling point of a liquid. We all know that boiling point of a liquid is a temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure. What is the importance of determining boiling point of a liquid? The boiling point of a liquid can be used to ascertain purity of a liquid. It is one criteria of purity of a liquid. Also, it can be used for identification of unknown liquids and also to find a suitable solvent for the chemical reactions in the laboratory. Now, let us understand, any liquid, uh, molecules from the surface, they keep moving into the air. No, they have enough energy to move into the air. And these molecules which enter into the air, they are at any temperature. The pressure which will be exerted by these molecules in the vapor state uh, will be called the vapor pressure of the liquid. And this pressure at a particular temperature is constant. As the temperature, as you start heating the liquid and the temperature rises, more and more of liquid molecules will go into the vapor state and the vapor pressure will steadily rise. At the boiling point of the liquid, as I said, the vapor pressure will equal the atmospheric pressure and hence the boiling happens. Now, I mentioned the term evaporation. Let us compare and understand the difference between the two terms, evaporation and boiling. Fundamentally, evaporation is a surface phenomenon. The molecules from the surface will move into the vapor state, whereas boiling is a bulk phenomenon. So molecules not only from the surface of the liquid, but also from the bulk of the liquid will move into the vapor phase. Now, at temperatures below the boiling point of the liquid, the molecules in the bulk do not have enough energy. No? So only the molecules at the surface have enough energy to move into the vapor state. But as the temperature rises, what happens is more and more of molecules have enough energy to overcome the intermolecular forces of attraction. And at the boiling point of the liquid, the molecules in the bulk also have enough energy to overcome the intermolecular forces of attraction and move into the vapor phase. And then we say that the boiling is taking place. Now, it is very important to understand, all of you might have observed that when the liquid boils, the temperature of the liquid remains constant. This is happening because the heat which is being supplied is absorbed as heat of vaporization, meaning the energy given on heating is used to overcome the intermolecular forces of attraction and move from the liquid state to the vapor state. That is why, as I said, you will find that temperature at the boiling point of the liquid will remain constant. Now, let us take a look at the factors which affect the boiling point of a liquid. There are ideally 4 factors which affect the boiling point of a liquid. First is the molecular weight. Now, if you look at molecular weight, the intermolecular forces of attraction, they determine the boiling point of the liquid. Stronger the intermolecular forces of attraction, higher will be the boiling point of the liquid. So as the molecular weight increases, you will find that the van der Waals forces of attraction and hence the intermolecular forces of attraction are increasing. Therefore, the boiling point of the liquid increases. Now, as the branching increases, what we'll find is that the surface area is going down. So the van der Waals forces of attraction are going down. Therefore, the boiling point of the liquid will drop. The third factor is polarity. Now, polar molecules, they have strong dipole-dipole interaction. They have strong intermolecular force of attraction, because of which they require higher energy to overcome the intermolecular force of attraction and move from the liquid to the vapor state. That is why polar molecules will boil at higher temperature as compared to the non-polar molecules. The fourth factor which affects the boiling point of a liquid is the hydrogen bonding. Polar molecules, they also have, especially, in case of molecules which have hydrogen bond donors and hydrogen bond acceptors, they can form strong intermolecular hydrogen bonding, because of which higher amount of energy is required to overcome the intermolecular forces of attraction, and the boiling point of the liquid will increase. Now, let us look at what is the effect of impurity on the boiling point. You have studied colligative properties, and you know that impurities lead to elevation in boiling point. Ideally, when you talk of pure liquids, they have sharp and well-defined boiling point. However, the reverse is not always true. If you find that there is a liquid which has a sharp and a constant boiling point, it does not necessarily mean that it is pure, because if you recollect, you have studied about the azeotropic mixtures. I will just give you one example. For example, a mixture of 95.6% of ethanol and 4.4% of water forms a constant boiling mixture, azeotropic mixture, and it is boiling at a temperature of 78.1 degrees centigrade. So at this temperature, such mixtures you cannot separate, they will boil as such. So, as I said, that pure substances have constant boiling point, but the reverse may not always be true. Okay, as I said, impurities lead to elevation in boiling point. Depending upon the nature of impurities, you can have different effects being observed on the boiling point of a liquid. So if you have a non-volatile impurity, the liquid will boil at a constant temperature, and the entire liquid will boil up, and the non-volatile impurities will be left behind. Whereas if you have a volatile impurity, in that case, three situations may arise. The first is the impurity is forming a constant boiling mixture with the liquid whose boiling point you are determining. In that case, you will have a constant boiling point for the azeotropic mixture. The second thing is, you may observe that the boiling point of the liquid steadily increases. The third thing that you may observe is that the boiling point of the liquid rises in steps. So what phenomena is observed will depend upon the type of impurity and the amount of impurity which is present in the sample whose boiling point you are going to determine. Next, let us look at the methods which are used for boiling point determination. So in the laboratory, we are going to use two methods for boiling point determination. First of those is simple distillation. And this is the setup that I have for you. You have a round bottom flask here. Here we will have a source of heating. I will explain what that is going to be. Now this is attached to a two-way adapter. On one side, you have a mercury jacket with thermometer in the mercury jacket. On the other side, you have a water condenser which is attached. There are two openings here. The one at the further end is used as an inlet for water using rubber tubings connected to the tap. And the one which is closer to the RP is used as an outlet for water. This is then attached to a vacuum adapter. The two-way adapter, you can have a vacuum pump attached here, and the other side is attached to a receiving flask, which may be cooled in water or ice depending upon the boiling point of the liquid. Okay, so why we need vacuum pump here in some liquids is that when you have liquids which have very high boiling point, and especially liquids which decompose at their boiling point. So in such cases, the distillation has to be done under reduced pressure. So for such liquids, the vacuum pump is attached here so that the distillation can be done under reduced pressure conditions. So the liquid is filled here, about half filled in this RB. Okay. And you have to put one pumice stone to ensure that there is uniform heating taking place. The source of heat will depend upon boiling point of the liquid. If the boiling point is less than 80 degrees centigrade, then you can use water bath as a source of heating. And if the boiling point of the liquid is more than 80 degrees centigrade, then you could use sand bath, or you can also use the Bunsen burn. We will demonstrate both of these when you do the experiment actually in the lab. So when you start heating from here, what will happen is gradually the temperature will rise. As the temperature approaches the boiling point of the liquid will evaporate, move into the vapor stage. These vapors will rise from here. They will come in contact with the cold water, which is circulating in the R2 jacket here, in the outer jacket. So these droplets of pure liquid will condense and they will pass through this area, and then they will be collected in the receiving flask here. So that is the simple procedure for doing the distillation of a liquid to determine the boiling point. We have an improvised and a safer method which we also use in the undergraduate lab to determine boiling point of the liquid, and that method is called the Botmel method. So that is the Botmel. If you see, there are two finger-like projections here, and there is on the neck, you have space to put the cork with the thermometer inside this. There are two jackets, the inner jacket here where the liquid whose boiling point is to be determined is placed, and you have an outer jacket here which is for heating. In between the two jackets, you have air gap. So when you heat the outer jacket, the air inside gets heated up, and that heated air is actually heating the liquid which is carried in the inner jacket. There is no water condenser required because there are two different jackets. The apparatus is safer for undergraduate students. So even if you have some accident and the outer jacket breaks, the liquid is held inside the inner jacket and nothing will splash onto your body, or it will not cause any injury to you. Plus, there are some air holes here to release pressure. So there are no situations under which pressure will be generated or the Botmel apparatus can burst. So what we do is we will put 1 to 2 ml of liquid in this inner jacket. We adjust the cork with the thermometer in such a way that the tip of the thermometer is in line with the fingers projections here. Okay. And securely clamp this on the clamp stand, suspended in air. Now, with the help of a Bunsen burner, we will uniformly heat here. The air inside gets heated. This hot air will heat the liquid inside. As the liquid approaches its boiling point, the liquid will evaporate. The vapors will come in contact with the cold surface here, and they will get collected in these finger-like projections here. Okay, so these are the two methods that we are going to use for boiling point determination in the lab. So let us just go through the procedure one more time. You will securely clamp the Botmel apparatus in such a way that the finger projections, they rest just above the clamp. Using a long glass dropper, you will introduce the given liquid right at the foot of the inner jacket. Okay. And then you will ensure that no liquid is entering into the finger-like projections. A small boiling chip or a porcelain chip is put to ensure uniform heating and prevent any sort of bumping from taking place. Then you introduce the thermometer fitted with the cork in such a way that the bulb of the thermometer is in line with the finger projections. Okay. Secure the cork and ensure that it is not too tight. And then you start heating the outer jacket of the Botmel uniformly with a small blue flame in a circular manner. Okay. The pure liquid will distill and it will collect in the finger projections along the sides, and temperature on the thermometer at this point you will see will become constant. That will be the boiling point of the liquid, and you will note this temperature. So I think I have explained both the procedures, simple distillation as well as Wadman method for determination of boiling point of the liquid. I hope now you will be able to perform this experiment in the lab. Let us start doing it in the lab now.